Assalamu alaikum. Welcome back to School of Physics. Here today I will discuss a new topic which is regarding the forces. I will write it down first. The fundamental forces of nature. Fundamental forces of nature. So in this regard, I will discuss what kind of forces are there on the primary level, which are existing inside the universe, which are governing our universe. Right now, as of now, we know about the physics, developments in the physics, and we have up to now we have concluded that there are four major forces which are fundamental in nature, which are understood to some extent or a greater extent. So what exactly is fundamental? What does fundamental mean? Fundamental means the basic, that is, which is, we can say, the thing, anything which is the primary source, that means anything which is the primary source of all other things. That very thing is called as the fundamental, whether that may be force or whether that may be some other aspect of physics or other subject. That is called as the fundamental. That is the thing which can't be further divided. That is the basic component of that very aspect. That's called as the fundamental. For example, you will get an idea about it in a while. First, before that, I will discuss what is force. I will give you a simple definition, a short definition about force. You will always recall that. You have to remember this very force. We generally speak about the force as push or pull, but that is not all there it is. No, there is something beyond that, because for example, you are able to watch right now your your video on your smartphone, PC, whatever it is, on the TV. So there is something happening inside your smartphone. The rays comes out, strike your eyes, and you are able to, and your mind perceives it, and you are able to get the image or video in your mind that this stuff is going on. But from mobile phone to your eyes, what exactly happens? There isn't any push, there isn't any pull, but still then a force is acting behind that. A force is working over onto that very phenomena, which is making you to feel that you are observing something, you are seeing something. So for that, I will give a simpler definition. An agent, or you can say any agent, an agent which causes a change in the universe. I told you earlier, this universe is very much important. So that's why the title of my channel is also School of Physics Understand Universe, because the basic module here is to understand our universe. An agent which causes a change in the universe, that is the force. That agent, this very agent which causes a change in the universe, maybe it may be part of universe, part or as a whole, part of universe. Okay, so an agent which causes a change in the universe or in the system, we can say for short, that is the agent which is called as the force. That agent is called as the force. For example, your pen is here it has some position at some time, but as the time passes, it is shifted towards this very position now. Unless and until there isn't any force acting over onto this pen, it is not possible that it can change its position. Since I have applied a force on it, so that's why its position has been changed. So there is a change in the state. State of the position is what? State of the pen is what? First it was on this place, onto this place, and then on applying force, it got changed its position. Okay, so there is a change, and the change is caused by some external agency, and that agency is force, which in this case my hand is applying force onto this pen. Another example. For example, here I am having this pen lifted in the air. I am dropping it. I am not applying any force over onto it, but this still drops down because there is some agent which is causing change its height from h to 0 position, the ground level, and that very agent here in case of this is gravity. That's the gravitational force of the earth. So here the agent is gravitational force, and that's also force. So that means it's not only the push or pull. You can make a generalization of this very statement like this: an agent which causes a change inside the universe, in the universe, that very agent is called as the force. So there can be different types of forces. We use in our day-to-day life various kinds of forces, like we use in our common language that it's frictional force. If we have water and honey in 2 glasses, we drop down, we say one has got more viscosity, another have got less viscosity. That means the viscous force acting on honey is more than that of the water. That's another force, the viscous force. Another thing you observed, when you are inside the water and dropping something inside the water, you feel that its weight is lesser. When you get it out of the water, its weight increases. So there is some kind of weight downwards, but inside the water there is some stuff, some kind of force which is acting upwards, which is making the weight lesser inside the water as compared to outside the water. So that very force, which is called as the buoyant force. Another force we use in simple languages, which is inside the human body, our muscles, which is called the muscular forces. So we, in our common language, these are not the fundamental. I have already told you fundamental is that very thing which is primary source for anything. Anything which is primary source, that is the fundamental. Okay, so in this regard but in our day-to-day life we use various terms for forces, like we have muscular forces, we have spring forces, which I have not discussed yet. Spring force, for example, we have a spring. If we compress it, we feel like we are the spring is exerting some kind of force onto our hands, and that force is called as the spring force. Another, as I told you, the buoyant force, many other forces. I will discuss here few, like the frictional force, the contact force, which is, for example, the contact between two particles, the contact between two things, we can say. So there are various kinds of forces, but these are not the fundamental ones. So I told you that these are not the fundamental forces. For example, take the example of spring force. This is a simpler one to understand. The spring force. For example, we have a spring. We are compressing it from this very position x to this very position, x minus some delta x. So we are compressing this spring like this, and when we compress this very spring, we will feel that there is a force exerted from this spring, okay, over onto our hands. But that is not the fundamental force which is existing there inside the spring. It is the electromagnetic force. How that is? Electromagnetic force. Look, spring consists of molecules. Say for example steel or iron or carbon, iron and carbon. So this is the composition of a spring, which is spiral in shape over onto something. So we will get a spring shape of this very steel rod, okay. But molecules are present inside the spring, and these molecules are itself made up of atoms. And these atoms, when these are present, say for example this is the portion of the spring like this, when we take this very portion, it is made up of atoms, and the adjacent particle to it, it's also made up of atoms. There is an atom, there is an atom, there is an atom. And inside the atom, you know, there are protons inside the nucleus, and around which electrons are revolving. So there arises some kind of strain, which is the force created between these particles, which are charged in nature, charged particle in nature. So the force which arises between the charged particles, this gives rise to the force which is observed on a macroscopic level. I have earlier told you that there is a kind of reductionism which you must be understanding first, because we have reduced this spring, the macroscopic entity, into a microscopic entity based upon the atoms and molecules. So we have reduced, there is a kind of reductionism, there is a kind of reduction. So for that, inside the charged particles, we know the force existing between the particles. It is the electromagnetic force. Electromagnetic. So this force gives rise to what? This spring force. So there is a strain caused inside the spring, which is not caused by spring itself, but it is due to the particles which are present inside, the molecules present inside the spring, which is causing a strain on the macroscopic level. So the spring force has its origin, has its fundamental basis lying inside what? The electromagnetic force. Though we are observing spring force, but the fundamental action is going on the molecular level, on the atomic level, which is caused by electromagnetic force. So the fundamental source of spring is itself what? The electromagnetic force. So electromagnetic force is the origin of spring force. Similarly, muscular force, it is also based upon the chemical reactions taking place inside our body. Inside the body, the chemical reaction taking place inside our body, and the chemical reactions are itself composition. These are the composition of the molecules and atoms, and atoms and molecules are itself made up of electrons and protons, which are charged in nature. So the fundamental force here also existing is also the electromagnetic force. Similarly, in case of other things, you will see either there is gravitational force existing behind that very particular thing, or there is electromagnetic, or in case of nucleus, there are two other things. strong force, strong nuclear force, and another is weak nuclear force. So that means all the forces which are we observing in our day-to-day life, these come under 4 category of the forces, and those 4 forces are fundamental in nature. There is no further reduction in that very thing. That force has no further source. That's itself the primary source. So that's why these are called as the fundamental forces. And there are 4 fundamental forces inside our universe right now. Although there is dark energy, dark matter, which are having different domain, and maybe there is something else, there is some another force behind that, but that is not our domain of physics, which we are discussing right now. So leave that very portion aside. But basically we are dealing with the physics, which is well established. So in that regard, we have 4 forces of nature, 4 fundamental forces of nature. First is the gravitational force. First is the gravitational force. About the gravitational force, this is one of the, I can say this is the most ancient discovered force to the humankind. It was known to the humankind centuries and centuries back. Okay, so humankind, man was knowing the about the gravitational force very much from the very much beginning, but this gravitational force is most complex in nature. It is not yet understood completely. Okay, so this is most mysterious gravitational force, this most mysterious force among the fundamental forces of nature. So this is I can say this was well known to man many centuries earlier, many centuries back. So about the gravitational force, since we are dealing with right now, we are dealing with the classical physics, classical mechanics, or classical or Newtonian mechanics. So I will not get into these gravitational forces so much deeply that you will get diverted to some other stuff. So we will deal with the Newtonian mechanics only. In that regard, Newton himself gave an expression about the gravitational force. So gravitational force, which is one of the first part of our fundamental forces, F, this gravitational force is given as equal to gm m by r square. What does that mean with a minus sign? That means if we have 2 masses, say for example m, capital mass here, and a smaller mass, or maybe they may be equal size, that doesn't matter anything, that doesn't change anything rather. So here if we have 2 masses and the distance between and the distance from their centers is r, distance between these 2 particles, 2 systems, 2 masses is r, then Newton's law of force says that the force existing between these 2 particles, these 2 systems, is given by force is directly proportional to the product of their masses. That is, G is directly proportional to the product of their masses, and inverse proportional to the square of the distance between them. That is the square of the distance. Distance is r. So this is also called as the inverse square law. Inverse square law, because it follows force inversely proportional to distance between the 2 masses, and the radius or r, which is the distance between the 2 particles, it is from this very center to this very center. So this very force is also known as the central force. I write here the central force. Okay, so it follows inverse square law, and gravitational force is given as equal to minus gmm by r square, where m is mass of one body, small m is the mass of another body, and r is the distance between them in the center. What does this between their centers, what does this minus sign indicate? This is very simple. Minus sign indicates that F, that is, which is gravitational here, I will write it down subscript as G. Gravitational force is attractive in nature. Attractive in nature. Attractive in nature. So that is attractive. Whenever there is a kind of attraction between the two particles, the force which is existing between them, we indicate that as negative, because negative indicates, for example, take a body here which is mass m, this is the center, and another mass, say it is here. If we locate this very point with respect to this mass, bigger mass, this is smaller mass, as some radius, or we can say some position, this is called as the position vector, or position vector. This is called as the position vector. You will come across this further in the subsequent classes. So if this is the vector position vector of this very point, of this very mass, then the force existing is gmm by r square. But what is the direction? Since it is attractive, so this very particle will have a force heading towards the bigger mass, towards this very mass. So we have seen that the position vector is heading towards this, that is r is heading towards this, but the force of attraction, force of gravitational force, is heading opposite to it. Since these two are opposite, this opposite nature is indicated by a minus sign, indicated by negative sign. This is the significance of minus. Otherwise, if you put no minus there, it won't change any physics. Just you have to remember that the gravitational force is attractive in nature. And there is some G here. This G is called as gravitational constant, or universal constant, whatever you can say. Gravitational constant. Gravitational constant. And its value is given to be, it is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg. Per kilogram square. How this is calculated? This is simple. I will show you shortly here. So for that, what you had to do, look, we have force is equal to, keep aside this minus sign because minus is with no units, g mm by r square. We have to calculate the units of g. Units of g. Look, g is equal to, cross it, this will come down, this will be written as f multiplied by r square divided by, on the m and m comes on this side in the divided form, so it will be written as m. So g will be equal to, from this g will be equal to f multiplied by r square divided by m into m. What is the unit of f? Units. Unit of f is Newton, which is represented by N. R is the distance between the two masses, that is the distance, and the unit of distance is meter, but it is squared. So Newton meter squared per or divided by m. M is mass, small m is also mass, and the unit of mass is kilogram. But this is mass into mass, that is kilogram into kilogram, that is kilogram square. So this comes to be the units of G, the gravitational constant. So this was the basic, the fundamental force, first fundamental force, which is the gravitational force, and it exists between gravitational force, or simply gravity, we can call it gravity as well, gravitational force, but that has its own domain, you have to recall that also. Gravitational force, where it is applicable, it is seen on the whole of the universe, it is seen everywhere, between the stars, galaxies, planets, even our solar system. This is sun and this is our planet, the earth. This is revolving around the sun, and that is also based on gravitational force. Okay, so this gravitational force, it has range of infinite, we can say, because it is seen everywhere. Even though it is small, it is very much weak force, but it has a longer range. Then comes our second force, second fundamental force. That's also a square law following, which is electromagnetic force. This is second fundamental force, electromagnetic force. And this electromagnetic force, you have to remember about this, it only exists, only in case the particles between which it is existing are charged in nature. It exists only between charged particles. So if the particles are charged, if the masses are charged, if the bodies, if the systems are charged, then only this very force is existing. For example, this is a particle A, or the system A, this is another system B. If this has charge 0, this has charge 0, no attraction or repulsion, whatever it is, no electromagnetic force. If no charge means neutral. We have to have at least and at most both of them charged, because if one of either of them is neutral, there is no effect, there is no electromagnetic force existing. So these two must be with some charge. Say for example, this charge is represented by Q, this is Q1 charge, this is Q2 charge. This very particle has Q1 charge, this very particle or system has Q2 charge, and the distance between the centers of these systems, again take it as R. So this is also a central force in nature, central force, and the force is given by Coulomb's law, which states that force between the two charged particle, Q1 and Q2, the two charged particle, is equal to, similar in case of the gravity, there were two masses, here are two charged, Q1 multiplied by Q2 divided by R square. So that means this is also a square law. Inverse square law, because it is inversely proportional to the square of distance between the two particles. And there is a constant, like in case of gravitational force you have seen the constant g, and here the constant is 1 divided by 4 pi epsilon 0 or epsilon naught. So this epsilon is called as the electric constant, you can say, or the permittivity, short permittivity, or vacuum permittivity. You will come across these things again and again in the upcoming classes, so don't worry about the hoo-ha of these names or something else, so be cool. So force law, which is Coulomb's law, is for F is equal to 1 upon 4 pi epsilon naught q1 q2 by r squared between two charged particles having the distance r between them. Now comes the portion, this whether it is positive or negative sign to put on here. So in case of here we don't put any sign, so no sign. Why? Because maybe the two particles q1 and q2, maybe this is positive, and we know like charges repel, then there must be repulsion. If this is positive, this is negative, then there is attraction. So it depends upon the charge, what kind of charge it. If it is negative and it is negative, then again repulsion. So if charges are of same nature, then there is a repulsive force existing between them, and that is repulsive Coulomb's force. And we know repulsion, with the force which is repulsive in nature, it is positive. And in case it is attractive, that is the q1 and q2 are of opposite nature, one is positive and another is negative, that means there will be an attractive force existing between them, the electromagnetic force of attraction. So in that regard, like the gravitation, it will come negative, but that depends upon the charges. So for better, it is not written down here, neither plus sign nor minus sign. So it depends upon what kind of force is existing between the two particles. And the value of about this permittivity, value of permittivity is equal to, this is called as electric constant also. Its value is equal to 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. In a similar case, in a similar fashion, you can calculate the units of epsilon as previously I calculated from gravitational force. You can calculate from the Coulomb force. Just put it down, like just cross multiplying the things and rearranging the stuff, you will get you have only to note down that in case of gravitational force there was a mass, but here it is charge, and the charge have the units of Coulomb, which is represented by C. Only thing you have to do. So that means C into C means C square divided by R square means meter square. This will be multiplied to this, okay, Newton meter square, and Coulomb square will be like this, and this E naught or E0 will be replaced by F here. So F has units of Newton, it will be in the denominator. Okay, so you have got an idea about these very things. And I have also already told you that this electromagnetic force, almost all the forces which are observed in our daily life, in our day-to-day life or daily life, have the fundamental force existing as electromagnetic force. The fundamental force behind all of those forces, like muscular force, viscous force, the viscosity inside the fluids, the buoyant force inside the fluids or liquids, and the spring force which I discussed earlier, the contact force, the frictional force which is existing between the two systems when they slide onto each other. So all of these forces have fundamental force as this electromagnetic force. So these were the two forces which are observed in our day-to-day life. Gravity is also observed like this. Electromagnetic force is also observed in our day-to-day life, like I said, in the muscular forces, spring forces, frictional forces, or other stuff like that. But there are other two forces which are existing inside the universe, which are existing inside the nature, and those two forces are called as the nuclear forces. Those are called as the nuclear forces. Nuclear forces. There are two nuclear forces. These are of two kinds. One is the strong nuclear force, another is the weak nuclear force. So for example, take an atom. This is an atomic nuclei, and around it there is an electron revolving around it like this. So this is nucleus. We know the atom is stable particle. Atom is stable particle, and between since nucleus is positive charged and electron is negative charged, there must be a force of attraction between these two, which is giving rise to the centripetal force around the nucleus, or in the quantum mechanics you will come across another stuff which is given by Planck, Bohr, Rutherford, some other physicists and some other people. So you will come across those very concepts, but here the electromagnetic force must exist. And inside the nucleus you see only two kind of things. Either there are neutrons or there are protons. These two kind of things are present inside the nucleus. So that means nucleus has two charged particles. One is neutron. Neutron is neutral. That means neutral charged particle, neutral particles which have no charge. And another kind of particle is proton, which are positive charged. So that means overall nucleus is positive charged. Then if there are inside the nucleus there are two protons, proton and proton, there will be a repulsion, isn't it? There will be a repulsion between the two protons. Then how does atom is stable? Here comes for rescue the nuclear force. Here comes for rescue the nuclear force, which is the strong nuclear force. For the basic elementary idea I will give you, we will discuss here the first to the third kind of fundamental force, which is the strong force, strong nuclear force, strong force. So this means this kind of force is existing between the nucleons, Upon studying the advanced physics, you will actually see that the forces are not exactly between the two nucleons. There is further division of the fundamental particles. So on the basis of that, you will come across those very concepts in advanced physics, in advanced mechanics or advanced physics. So don't worry about that. I'm just giving an rough idea about the strong forces. So this strong force exists between the nucleons, like between proton and proton, or proton and neutron, or neutron and neutron itself. Even though these are neutral particles, but still then strong force is existing between neutron and neutron. For these various theories were given, like Meson Theory by Yukawa. This was the first theory which was suggesting that there is a kind of particle, the pi meson, which is being shared between two protons, or between one proton and one neutron. Exchanging of them will result in a force, but that is some advanced kind of stuff. So don't worry about this very theory. These all will be dealt with due course of time. So for now you have to remember that strong forces, this has this range of action inside the nucleus between the nucleons. So it exists inside the nuclear domain. This is nucleus, and its range, I can say range or domain. For now I will use the term domain. It has the domain which is of the order of 10 to the power minus 15 meters. 10 to the power minus 15 meters, such a small size. So its range, so that is the reason we are not able to observe any strong force in our day-to-day life, because its range or its domain is only confined to nuclear dimensions, which is 10 to the power minus 15. Furthermore, it was suggested that these protons and neutrons are not having the fundamental force of strong forces as the fundamental, but these are further divided into some particles. Not divided, I can say these are further constituted of some further particles which are fundamental in nature, and those videos called as the quarks. For example, I will take a proton. This is a proton. Proton is further constituted of 3 particles: up, and down. Up, down particle. These are called as quarks. Up quark, down quark, up quark. When these kind of particles are held together, and these are held together by gluons. These are advanced topics, so don't worry about this, just have a flavor of this topic. Don't go so deep. If you don't understand anything out of it right now, no need, no worries. It will, in the subsequent classes in the advanced physics, you will come across this very stuff. So proton is constituted of quarks, like up quark and down quark forms one proton. Similarly, neutron, it is formed by up, down, down. So this is up, another, there is instead of up there is down in case of neutron, and down. Up, down, down constitutes of neutron. Up, down constitutes. And further theory says that this is the strong force which is existing between these quarks. That is the strong force. So basically, whatever it is for you just now, remember that these forces are existing between the nucleons, because this is a nucleon itself. Whether it is existing inside the nucleus, or existing between the nucleus, between the nucleons, but it is the fundamental, because it can't be further divided into some other force. There is no force behind this strong force. This is one of the fundamental force, and its range is 10 to the power minus 15. Even one thing more, strong force is 100 times stronger than electromagnetic force. This is 100 times stronger than the electromagnetic force. So you have to remember just an elementary idea about this very stuff. Another force which is fundamental in nature, the last one, which is the weak force. I will give just an elementary idea, because these are the complex topics in the advanced physics. You had to remember, and you had to understand very much high concepts about it, first of all, to understand the reality behind all these forces. So I'm here just giving you the idea where are these applicable, where does these forces exist in exact cases, in actuality. So weak forces is the fourth type. So for that, weak forces have like in case of strong force, I have told you that it has the domain of 10 to the power minus 15 meters, and its domain is further lesser than that, 10 to the power minus 50 lesser than that meters. And these weak forces, these only appear in some nuclear processes, like beta decay, What is beta decay? You will come across this very thing. I will give an idea about it. Like if we have a particle neutron, this is a particle neutron. If this particle neutron is inside a nucleus with radioactive nature, that is disintegrating nature, disintegrating nature, that is it decomposed, that is the nucleus is with the passage of time it decomposes into further smaller things. So this neutron gets decomposed, gets converted into a proton. This is neutral charge, this is positive charge. To conserve the charge, we have to have another particle is coming out of this radioactive nucleus, which is negative in nature, and furthermore another particle, this very thing. What are these exactly? This is proton, the positive charge. This very thing is called as the beta beam, which is coming out of the beta particle, which is coming out of the nucleus. To conserve the momentum, in the advanced topic you will come to know, we have another particle coming out. This is called as the anti-neutrino. It is, in some case you can say, the opposite to neutrino, anti-neutrino. So this is the beta decay here. When a neutron decays, in case of the radioactive element, in case of a radioactive nucleus, neutron gets decomposed into proton plus electron plus anti-neutrino, and this beam forms the particles called as beta particles. So you have observed that you have seen that there are 4 kinds of forces which are fundamental in nature: the gravitational force, the electromagnetic force, 2 other nuclear force. One is strong nuclear force and another is the weak force. So regarding that, I will have a comparison of their strength comparison. Just few more minutes to complete this topic. Strength comparison. Say, for example, for gravitational force, we will take a unit strength, 1 unit strength. Okay, then in case of, then there is after that, if we have gravitational force of unit strength, the second one which comes as more stronger than this gravitational force, because this gravitational force is the weakest among all the fundamental forces. This is the weakest force of all the forces, and it's mysterious. You can see that the force which is running mechanism of all the stars, planets, Earth, Sun, every stuff on the celestial level, but its strength is so much weak, its strength is so much smaller. See upon the comparison. The second which comes, it is weak force, then the electromagnetic force, then after that the most strong is the strong force itself, strong nuclear force. Okay, strong nuclear force. What is the magnitude of there with respect to gravitational force? Because the gravitational force, I put it 1 unit strength. The weak force is 10 to the power 26 times stronger than gravitational force. Stronger than gravitational force. So 10 to the power 26 times 10 to the power 26 units. This very thing, electromagnetic, it is 10 to the power 36. This is an approximation, keep that in mind. This is approximation, it's not the exact value, I'm just giving the rough calculation, the approximation. This electromagnetic force is 10 to the power 36 times stronger than the gravitational force itself. See how much weaker the gravitational force itself is. Electromagnetic force is 10 to the power 36 times greater than having the strength of that of gravitational force. So 10 to the power 36 units. And you know stronger force, as I earlier told you, that stronger force is 10 to the power 2 times, that's 100 times greater than electromagnetic, which means that strong force is 10 to the power 38 times greater or more strong than gravitational force. See how much weaker this gravitational force is and how much strong in comparison between these two. How much weak this gravitational force is and how much strong this strong force is. But the only difference, the major difference, this is long range force and this is short range force inside the nucleons, which is existing between the nucleons. Short range force, this is the major difference. See this very thing and this very thing and see the huge difference between these strengths. Gravitational force is the weakest of all fundamental forces, but there is an attempt which is going on still, which we called as the unification of the fundamental forces. Unification of forces. Look, in the 19th century, Maxwell, this is a great physicist, you might have heard his name. He unified electromagnetism with optics, that is light stuff, dealing with the subject which deals with the light. So Maxwell in the 19th century, he unified these two things: electromagnetism, that is the forces which are existing between the particles which are charged, and optics, the light itself. That means he concluded that the light, the electromagnetic wave itself, is due to the formation, its formation is due to the interaction between the particles which are charged in nature. Okay, so he unified these two stuff, these two domains. Then in the 20th century, the physicists like Glashow, Abdus Salam, and other workers, they unified another two forces: this electromagnetic force, which is here, and this weak force. They unified this very thing, these two fundamental forces, that is electromagnetic force plus weak force. And now the attempt in the 21st century is going on to unify all other forces with gravitational force, and that is the unification of all the forces. That is some scientists called it as the theory of everything. So attempts are being made, but it is not successful yet, to unify all the forces of nature. So hope you got an idea about the fundamental forces of universe. There are 4 of them, and you have got an idea about them. I hope you have got it. Kindly support the channel, the School of Physics, understand the universe. I will see you in the next.